what we were going to talk about was the object model and the way things are going. We're still mid refactor, so things are still moving around a little bit, but for the most part, I think this is looking very good. And it's different. It's a little bit different than we had originally laid out. But I'm hoping it ultimately is much simpler for people to grok. And there's some aspects in here which hopefully people can help explain as we broaden the team and people doing this. So on screen I have the basics for what the model are, and there are a couple of key concepts that we anchor from. The first one is bar clamp. So a bar clamp is a module that basically holds the chef cookbook, and is the conceptual template, if you will. It's easy to think of it this way for how to deploy something. There's a lot of stuff that goes under it, but that's the holder for basically a template and the services that template provides. Okay. Those bar clamps themselves implement roles, so the real expression of a bar clamp's action are in its roles. So, for example, in the OpenStack compute project called Nova, that project has the concept of a controller, which provides sort of the scheduling infrastructure and the management infrastructure, and compute, which is the nodes that actually run the virtualization infrastructure and do the work. And so what we have as a common and required, ultimately, concept in Crowbar is that bar clamps are these big templates, but they actually decompose into roles that actually decide what to do and hold the resources. And so inside of a node, you actually inside of a role, you assign nodes, and those nodes are the actual things that have that actually are the entities that have deployments done to them. At some point, we were almost calling them entities, but that's confusing, so we're just calling them nodes. Nodes are physical gear that you can address, you can install an agent on, or at least address with an agent and take action on. So that's really the target of everything we do is a node. So bar clamp puts up roles act on nodes, and what they do to act on nodes is they make decisions based on the attributes that we have informed the systems that we want deployed. So if it was a Nova deployment, you would have attributes that describe the actual configuration of OpenStack, what ports to listen to, which virtualization platform to use, all those things. You would also have attributes that tell the bar clamp information that it needs from other bar clamps. So you would tell it where the Keystone server was, you would tell it where the SQL server was, you would tell it what networks have been set up for it, which IP address ranges to use. All those things get set up. And then you can also have the Nova bar clamp request things like a certain BIOS configuration or a certain RAID configuration, or ask to be attached to a network, a storage network, or a public network that it needs. So attributes are the glue that hook bar clamps together within the system. Okay, so this is sort of the four key concepts, which is why I laid them out here. The other thing that's important, we've spent some time talking about, is a JIG, formerly known as the CMDB, or Configuration Management Database. JIG, example of JIG is Chef for us, although we use the word JIG to try and make it more generic. So Chef or Puppet, but there's the concept of a script JIG, which would basically let you execute scripts, or a discovery engine, conceivably something like the Project Razor, or could be used. And a JIG has the concept of both in and out. So a JIG can be used to discover information and store it. A JIG, which is what we call the inbound path, and a JIG can also be used as the outbound path. So taking data that we have internally stored as attributes and pushing it into a deployment, pushing it into a system and actually making changes to the node. So there's sort of this whole component here. Something I have not modeled at all in this picture yet is the engine itself and how Crowbar actually operates on state and tracks state of things and makes sure that it's interacting in a way that's basically allows attributes to progress over time. So that is not yet expressed in this model. We have models for it. I've only been updating this for things that I've started to code. Okay. And I try to keep this live. I'm also not trying to make this all the properties and things like that. This is meant to be conceptually showing the links between things. All right. So I've talked through all this outside stuff. And the way I've been building this, I'll pause for a second for questions. Okay. That's where I was going to go next, and that they're blue for a reason around those lines. Okay, so I'll jump into that and also ultimately explain why there's this long dotted arrow to bar clamp. All right, so the objects I talked, all the white objects, really were the sort of the underpinnings. And what we had in the model and then what we've been working with is this concept of the actual, so bar clamp's a template. When the template gets deployed, we actually create an instance of that template. So the concept of instance and the reason why I have that suffix on those objects is that those three models are all about a point in time configuration's a little overloaded in the way, but really it's a deployment. So the way to think of the set of instance models, and they're really a coupled set, is that they reflect Crowbar's configuration of a system at that point, at a point in time, which is why they have the word instance in them. And so attribute instance is the actual value of the attribute for a specific deployment. So let's say we have this concept of OpenStack Nova. There's a bar clamp for it. OpenStack Nova has basically roles for compute and storage or compute and controller, and every one of the nodes in that has configuration that it needs to execute its role for that bar clamp. The bar clamp itself is just the template. It's the actual, all the values that you need to express that are the instance. And so every time you make an update to that set, you're actually changing the entire set. There's no real concept of changing one component for a deployment and having the same deployment. So part of what we do with these instance variables is that they're actually all linked together to a single point in time component, which is what the bar clamp instance is. So the bar clamp instance is effectively saying this configuration, this point in time, has these roles, and then these roles have this data assigned to it. So what happens is that if I make a change to it, I'd actually end up creating a whole new instance. So think of it as a data set. Wayne's giving me a funny look, so I'm pausing to see if I can explain it better. The only place we store data is, I'm trying to get some feedback from the room. The only place we store data is in the attribute instances. And so that set of attributes defines the deployment. that we were doing, right? That's the purpose. And so that set of attributes, which includes both node data and template data, role and configuration information, that information is collected for the bar clamp. Right. Does that help, Wayne?
I understand what you say those things do, but that doesn't clear up my discomfort with using instances of types. Instances are instantiations of types, and so I would be more comfortable calling that bar clamp. If the data in your bar clamp model never changes, why is that not static?
Actually, in this case, the word instance I think is exactly right, although I can see your confusion on it, because it's an instance of the bar clamp.
Yes.
Right, and so that bar clamp instance, the bar clamp instance is exactly right. It's an instance of the bar clamp. But
it's not a type. It's an instance.
It's an instance of the bar clamp.
But you have a class that is described as the instance. That's not. The class isn't the instance.
And so we'll wind up having an instance of an instance, and maybe an instance of an instance of an instance.
That's correct. That's part of the danger of the nomenclature that we had, where we used to call them proposals, which was actually more confusing in its own way, even though we got used to it.
Well, I don't know. Instance of an object.
I'm just confused, I tend to be in the Wayne camp here. This is a perfectly fine model, but I think we're mixing an object model and a object diagram, or a classifier diagram. Seems like it. Because you've got, bar clamps will be realized as instances of bar clamps, right? When they're instantiated, but it's still a bar clamp. When you instantiate a bar clamp, it's still a bar clamp. That's its type, right?
And that's effectively, this is reflecting that, right? So when we have a type of thing called a bar clamp in Crowbar, bar clamps are effectively types in Crowbar, and we have different types of bar clamps. When you go to deploy it, you are creating an instance of that deployment.
Yes, but you don't call an instance isn't a type.
That's right. Right.
I understand that. I just think you're going to generate a lot of heartburn from O types, because this kind of naming is
we're using traditional jargon for our specific models. Instance is very specific in OO as a live instantiation of a class that is an object.
Mm-hmm. No, we've had a lot of heartburn on the naming, so I'm not. Go ahead.
Maybe you could call bar clamp a bar clamp template. And then
Yeah, I mean, I think there's some valid components to it. I understand the concern. In some ways, I think of this as a deployment, but I have not found deployment to be a more productive word for this. Okay, but it is really, I think, accurate to say that when I want to know what instance of a bar clamp is running, in sort of the object sense, I have deployed an instance of a bar clamp. That is what these models will collect for you. So I have code that's deployed. There's an instance of that bar clamp in operation, and that instance, which is a bar clamp instance, has instances of the role that have been deployed with instances of the data that are mapped under it. So effectively what happens is when we go to deploy something, we take the bar clamp instance, role instance, and attrib instance, pull those together and inject them in the bar clamp's configuration. Okay. The trick here is that configuration is really just a pointer to the active. And that's one of the things that was confusing to people, is that configuration does not play a very big role for us. The configuration model is effectively just a pointer to, the simplest thing to do in my mind is to think of the bar clamp instance as a linked list of basically deployments. So every time the deployment changes, should be a new bar clamp instance. So that new instance, we could go forward or backward and change. The bar clamp configuration points to which one of those is active, and then Crowbar would take its job is to, and the engine's job is to go between a desired instance and the active instance. And so what the Crowbar engine will do is it will take the coming instance, which instance you want to achieve, and it will act on that instance until the engine feels like it's achieved it, and then it would move the pointer to make that instance active, that bar clamp instance to be the active one. So at any point in Crowbar's workflow, you're going to have basically layers, stack of bar clamp instances and their affiliated children, all as a set. Okay. And then when you want to make a change, you're going to create a new set, a new bar clamp instance, and Crowbar's job is going to be to work through implementing the new Crowbar instance, the desired Crowbar instance. Sorry, bar clamp instance. By expressing the attributes into the environment. It's going to send those changes to the jig as a series of runs, which you can see that map down below. But it's going to press those. It's going to interact with the jig to say input. Do this, do this, do this, do this, and then at some point, the Crowbar engine will say, okay, this bar clamp instance has achieved. Is complete. It's now the active instance, and it'll tell the configuration to move the pointer to that instance. Right? There'll be state changes and all sorts of things. Okay. But this is why I made them. I did two different colors for this because I felt that one set of models was about the deployed state, the deployment, and represented point-in-time snapshots of that, and then these boundary models represent the broader models that describe sort of that underpin Crowbar's main nomenclature. I actually see it all when I look at it. I try to visualize it in 3 dimensions. Really. Questions? They don't. Attrib instance has a role instance ID. Role instance has a bar clamp instance ID. And so bar clamp, which bar clamp you're in is actually inferred through that chain. And actually, it's appropriate to show you that. So part of what I've been working through, let's see. So the attrib instance, and I'm using the Rails relations considerably for this, but trying to make it natural. So attrib instance has an attrib and a node. Okay, it's not required to have a node; it is required to have an attrib and a role instance. So this is the three-way relationship that actually does that. And so every time you save a configuration in Crowbar, it's going to deep clone all that data. Okay, and that is part of how we will allow you to move backwards and forwards. If you want to move backwards to an old configuration, we'll have saved all of that instance, basically the instance of that deployment. And then so what happens is those are the three, but it has one role through role instance. It has a bar clamp instance through role instance. It has a bar clamp through bar clamp instance. So it actually rolls itself up. Just this is where what that arrow is, right? So this is the actual chain of custody for an attrib instance to tie back to a bar clamp. And then so I've been working to make sure that everybody has these friendly methods. So if you look at an attrib is going to have many instances of that attrib, many nodes through the attrib instances. So once again here, if I want to know which nodes it has, you can just ask it and it'll tell you which nodes have that. There's a underlying complexity here that I haven't yet expressed in code, which is you might have 6 versions of this attrib instance from previous bar clamp instances that you've put through, and only one of them is the active one, which might have just blown people's mind. There's 2 dimensions on this. So there is a precedence dimension, which says that I might have 3 roles that all have the same attribute defined. That's okay. And store the value on the node. And then in that case, I do want. So if you had a SQL server, a SQL cluster, and a generic SQL, actually, I'll do SQL Server and SQL Cluster. Both of them might have an IP address that's offered. Those would be the same, essentially the same attrib, but different precedence attributes. I've been trying to accommodate that. But there's also the interesting concept that if I've changed the configuration of SQL 3 times and it's changed the value of that attribute, those 3 things are also in the system. And so you have both this is the active one, and it's the value you should use, and the idea that this is the most important one, or this has precedence over the other ones. So there's both time values and overlapping precedence values. Not yet. I'm working up to that. State is computed. What state does is the attributes have the concept of having both a current value, the inbound value, and a requested value, which is the outbound value. And so state is calculated to tell you when those things are different. So if they're the same, then the attribute says I'm basically ready, I'm managed, or set, and if they're not, then the attribute calculates a state of active, meaning that it is in flight. There's some change being made to it. Is what? Oh, I'm open to changes. The thing I wanted to do in avoiding state names was to avoid somethings, unset, unready, things like that. Using in transition or something like that seemed fine. Active was just shorter than in transition, so or changing or something like that.
But it implies an inactive state.
Right. I have, and there's a concept of empty for something that doesn't have any value at all. Although taking into the time account for this nascent might be a reasonable alternative. All what makes the most sense to people. I'd also consider like fluid or change, dynamic or unstable. But
yeah, I don't think active would bring to other people's minds immediately the fact that it was about to change.
Okay. I'm open to other choices that isn't reflected in code anywhere yet. So, meaning nobody's consumed state yet. Would it be simpler just to say changing?
Sure. Yeah.
Let's see. Let's see. Where did my state calculations end up? No. Here it is. I have empty when there's nothing in it. Active. We were switching to changing. I had the concepts of managed and set. Set means that a person or the API set it. And so that request came in as a one-time thing. The term managed means that a jig is managing it. And to me, I chose to distinguish these things because API changes are not predictable, but managed changes are. So if I have an attribute that is managed, that means that we expect it to be regularly updated by the bar clamp that's managing it. And we do know which bar clamp is managing. So, right, part of this model, and this has been what I'm wrestling with right now in code, is there is no concept, actually that's true, most of the attributes are managed through a bar clamp. So attributes don't show up by random, right? They show up because they are being consumed and managed by a bar clamp. And the bar clamp actually has a population approach where it actually says these are the attributes that I'm going to consume and manage. Make sense?
So if it's managed, does that mean that API changes are allowed?
I hadn't gotten to that point yet. Reasonably, it is possible to say that. I haven't enforced it.
If that was true, then I would change set to free.
Huh. Free?
Well, it means you don't want an un, but it would be
Oh, I see. Huh. I see what you're saying. Free doesn't quite make sense to me because it makes it sound like the value is not.
Right. Settable, something. Yeah, I don't know. I just like.
Yeah.
Set doesn't say to me that it says that, okay, it has a value, but it doesn't say that it doesn't express the API set versus the bar.
How about if I did it like this? I don't like that so much. So really what you're saying is this is a given value. It's a placed value. It's
I don't have any freeze the best I could do, but I would
Overridden.
Not completely adequate.
no, it's not entirely an override. It's I mean, it's like one time. But it's not necessarily one time. We could call it direct, but I still set still of those is still the best in my thinking. But
Yeah,
you're saying somebody set this value. Yes, that's my rationale for that. People aren't consuming this part yet, so I'm happy to consider something else. But I felt like if I had requested an actual, then I needed a state that would tell you when they didn't match. Effectively, this set state tells you actual and request don't match. And they do that by saying it's changing. So that's changing says they're unequal. Maybe the right word is unequal. And okay, it's clear. All right. Yes. This is where I came back to active, because that means this data is potentially in motion. Suspect, delta. I mean, we could put delta in here. Would actually be the one I kept thinking of but didn't use. Right. So there's some type of transition. And Dave, Nason, the only issue I have with that is that it's, but it implies new, and this isn't necessarily. I mean, and maybe this is maybe new is. You like unequal or pending? Which one are you saying no to, Wayne? Right.
But we don't know that the new value will be different.
So along those lines, this would be the sense of this would align with what we've done for that in the past, which is ready and unready. So a value that is changing is unready. But maybe it's okay to do this as ready and unready. And a value that is managed is now ready, meaning you can rely on it.
I'm okay.
It could, sure. I don't know that we'd need to broadcast that, right? I mean, it's still unready. It's fine. It's more consistent with what we've used for state in the past. So, and then override for the one that's set by, an override is pretty clear also. If you set something from the API, you're overriding its management. That's an override.
Well, I guess my question is how is that different? Are you going to have different transitions out of that state?
Not necessarily. So we could do. No, that's fine. I'm okay with it like this. They're both ready. I mean, you set a value. The trick would be, would that do away with the proposed value? If I set the proposed value, but it's different, it's still unready. If the proposed value and the set value are both ready, I mean, we might not need to distinguish. I'm okay leaving it like this. And then if we need to distinguish between API values and managed values, and we do it. This actually is a safer path right now, where you basically have empty. I like just because that means nobody's done anything to it, because we have variables, things that show up as empty and are then unused, and maybe unused. I wanted to avoid unused, but. So now this is very simple. If we end up needing to distinguish between API or data or not, we can, but otherwise we're not. The variables are things are either ready or unready, and I think that's reasonable.
Yeah, that's okay. I mean, this may be one of those cases where it's helpful to draw the state chart or both. I think it's understandable. I think it's
Okay. Yeah, I mean, the data's going to be there under the covers. I'm perfectly cool with that. And for now, we don't have anything that consumes state at all, except some tests. And then, yeah, there'd been a version of this model where I only had the active attributes in the table, and that we still might end up needing to do that, but we'll get there when we get there. Right now, you have to make the assumption that there's only, in BarClamp instance, there's only one that will be active at a time. And so I need to think through that a little bit. But you'll have an active instance, and that active instance will be responsible for returning the active attribute. When you get there. And that means that when you have inbound data, it would populate the active instance only. Yep, that's right. Ooh, fun. Okay. There's a subtlety in that that's really interesting. And one of the things you'll notice is that the concept of node role is subsumed. Right, there used to be a table joining roles and nodes together, and that was completely redundant with this table. And so the idea of a node role as a standalone entity might come back, but for right now I'm trying to make it a component of the attribute instance, because it's a much more consistent management path if the linking between roles and nodes is just through this one table. Right. And then the subtlety for that is that when you create a new instance of a BarClamp, it won't have any node data initially. It will have it will have role data and instance data that's not tied to nodes. That's what we'll clone. And then the node data would actually be pulled in as we populate data from the node itself. I'm literally implementing that code right now, and it's tricky code, unfortunately, but what I just said hopefully at some point will make a lot of sense. I can show you where it's doing it, but it's actually we've gone 45 minutes, so I was going to stop and let people digest this. Yeah. It should. There shouldn't be. I don't want two models. Right. All that. This should be able to subsume everything. Right. And I'm starting to whack out the proposals and configurations and all that. Those things are being replaced with barclamp configurations and barclamp instances. Oh, and there's a couple of things that are bonused in this. That if you want to look at interesting parts of the code, a lot of the interesting code is in the barclamp model. No surprise. And what we started this pattern, and this pattern's been really useful to the point where I wouldn't call it. I was tempted to pull out 1x from here. But when we create the bar clamps, we actually import all the data from the Crowbar YAML file, and that pre-populates a whole bunch of goodness for us. The thing that was really interesting is we also pre-populate the template. We pre-populate the attributes and roles and role orders and all sorts of great stuff from the BC template file. So as part of creating a bar clamp, this is useful. When you create a bar clamp, you create an instance, which is the template. And everything is cloned from the template. It's sort of this orphaned instance. And so when you create a bar clamp, we build a template, which is a configuration instance, a set of role instances, and attribute instances that go with it. And we build that using the BC template JSON file. So it literally will read in that data, and it will learn all the attributes. It'll learn all of the roles. It'll learn the role orders. Learns all sorts of information from that template file and basically creates it. And then I have, along those lines, been working on, this is really useful to go through. I'm sorry I put it at the end. A screen that shows the graph of this. So this model shows up in this page of the bar clamp graph. So the Crowbar bar clamp, this is its parent, members, its template. It has this role order, and then I need to go with this pull. I'll actually start building all the attributes that are tied to it. And then it'll show you what configurations and all this stuff. So one of the things I'm doing to try and make this transition easier is I'm building this screen that actually shows you the object graph instantiated. So this graph instantiated using bar clamp as the top level thing. So it goes down this tree and actually all the way down to here. So those things are all linked together, and the data for it's populated from this import model. And then the thing that's giving me fits right now is processing the inbound data. It actually has to go in and it finds the attributes. If they don't exist, it builds them. Basically, this is the cloning mechanism. So it finds all the unset attributes when you get data in and then attaches them. And it does that using this jig map. And the jig map, this was confusing at first. The jig map is a bar clamp attrib jig map. So it basically says this attribute is managed by this bar clamp for this jig using some type of logic, some mapping description. And then that map actually is at the bar clamp level. It's not at the instance level. So it's applied no matter what. And I'm actually working. I've got this logic that I'm showing, the process inbound data logic, actually seems to be doing exactly what it's supposed to do. You have a relationship with a node through this chain, and when you get new data in, it looks to see if these things are related, and then it populates. It actually populates the data. Right. The reason why it's confusing is that this link is optional. So you have, before you have node data, you have a bar clamp role instance, attribute instance chain. And when you get node data, you create a copy of that attribute instance and then assign it to the node. Which probably means that I need to have a and then you can figure out these two relationships anchor that relationship, so you can then find all the related items. Okay. I know that's complex. I'm hoping this won't be the only time we talk about it, but I'm hoping this will get you started. If it's any comfort, this is a lot simpler than the model I started with over a week ago, which had all sorts of outgrowths to the side and really complex relationships between them. Last question before I close the bridge. Okay. Cool. Guys, and I've recorded this. I don't know if it's helpful, but hopefully it'll be helpful to somebody. And hopefully the recording worked. Cool. Let's coordinate it, because there's nothing proprietary, so I can post the video up to the list also. Thanks. All right, everybody. Ciao.